In the last few examples, we were looking at evaluating an algebraic expression, meaning we took a given value for the variable, substituted that in, and our final answer was just a number. Now we want to move on to simplifying algebraic expressions. We won't be substituting anything in place of the variable. Instead, we'll just be looking to see how we can combine terms to simplify the expression. And in many cases, our final answer will still have a variable present, unless those terms cancel out. So our final answer may be a number, but will more often be an algebraic expression, consisting of terms with and without variables. We can simplify algebraic expressions by combining what are referred to as like terms. We identify like terms by looking at the variable factor of a term. For instance, 4x and minus 2x are like terms because they both have the same variable present, x. Plus 5 and minus 1 are like terms since they also have the same variable factor, which is no variable factor, they're just constants. So constants can be added and subtracted, and then other terms that have the same variable factor present can be added and subtracted. In order to do that, we look at the coefficients for each term. So for our variable terms, we have coefficients of 4 and negative 2. So we can add, or in this case, subtract those coefficients to get a combined or simplified coefficient of 2. For the constant terms, we have 5 and minus 1. So we have a new coefficient or a new value for our constant of 4, meaning our simplified expression in this case will just be taking those updated coefficients, which will give us 2x plus 4. Before we combine like terms, we first need to look through our problem though and see if there's anything that needs to be simplified using order of operations. For instance, in example 10, our second term is 4 times b times 3. The first thing we need to do is multiply those numbers together to get a single coefficient with that second term. So we'll rewrite this as 8b minus 4 times 3 will give us 12b plus 1. Now we can combine the coefficients on those variable terms. 8 minus 12 will give us negative 4b. And since we have no constants to add or subtract from the 1, we'll just have plus 1. In example 11, we'll start off by simplifying the arithmetic step that we have inside that set of parentheses. This will give us 5L divided by 3L times 9 minus 6 will be 3. Now we'll still follow order of operations since we don't have terms to add and subtract here. Our next step will be this division step. But keep in mind we have two different ways that we can write division. And I just switched to a different way of writing my L's, which I tend to do. So let's go back and make these L's cursive to match these other L's. 5L divided by 3L can also be written as a fraction. 5L over 3L, which we can still read as 5L divided by 3L. Then any value divided by itself will just cancel out to 1. So 5L divided by 3L will reduce to 5 over 3, or 5 divided by 3, times 3. This means our last step is this multiplication step. If it helps, keep in mind that we can always write a whole number as a fraction over 1, and then we can see how these values will cross cancel. 3 divided by 3 will just reduce to 1, and our final answer here will just be 5. In example 12, we actually want to work a different example than what I have here. We're going to update this problem to be 4n minus 2 times, inside a set of parentheses, n minus 3. This problem is a good example to take a look at because it's going to refresh us on what's referred to as the distributive property. When we look at that expression inside the parentheses, we have n minus 3. Those aren't like terms, so there's nothing we can simplify or combine in those parentheses. But what we can do is take that 2 out front, or actually a negative 2 in this case, and distribute it through that set of parentheses. The distributive property tells us that if we have some value a times a quantity b plus c, that's the same thing as a times b plus a times c. We'll use that property here to rewrite this expression as 4n minus 2n. Since that's a negative 2, that negative carries through. And then we'll take negative 2 times negative 3 to rewrite this as plus 6. Then we'll take care of the subtraction step to combine our like terms. 4n minus 2n will leave us with 2n, and there are no constants to combine with the 6, so we end up with plus 6. In example 13, we have what looks to be a lot going on, but if we just keep in mind the same processes we've been using for the previous examples, we can start off by simplifying everything that's in parentheses first. To make our problem 9x plus 4x times 5. And we'll go ahead and combine this, complete that operation in the second set of parentheses at the same time. 2x plus 3x will be times 5x. Next, we'll take care of those multiplication steps to give us 9x plus 20x minus 20x. And then we'll look at combining like terms following order of operations. So our first step will be to take 9x plus 20x, giving us 29x minus 20x. Then will leave us with just 9x. We could also take care of that all in one step. Since these are all like terms, we could just add all of those coefficients in one step. Or we can break it down into smaller pieces, take it a step at a time, just as we feel comfortable with that.